Hey there, welcome back to another video, and here we're going to discuss about how switching actually works. So in last video we talked about how switching logic actually works, and in this video I'm going to demonstrate you about the forwarding, how the forwarding actually takes place. So we're going to use again a simulation software called Cisco Packet Tracer, which is developed by Cisco itself, and it is pretty easy for the course to be used for all the labs that are mentioned for this course. So moving further, now we're gonna see how like verifying and analyzing Ethernet switching actually works. So a Cisco Catalyst switch comes from the factory ready to switch frames, or you could say ready to forward packets, and all you have to do is basically connect the power cable and plug in the Ethernet cables, and the switch starts forwarding frames. Okay, so you can connect multiple switches together, and they are ready to forward frames between the switches as well. And the big reason behind this is because the default behavior has to do with the default settings on the switches. So Cisco Catalyst switches come ready to get like busy switching frames because of the settings, like the interfaces are enabled by default. Okay, you don't need to start any interface, just like we did on the router while we were practicing VLSM. Okay, so over here all the interfaces of the switches are on by default. Okay, they just wait for the cable to be connected with the end device, and everything will be up and running. Also, all interfaces are assigned to VLAN 1. Okay, and you could say they have auto negotiation on between them. So you could have like 10 Mbps connection, or you could have an Ethernet port or a fast Ethernet port, and those ports can be different. If you have a port over here, let's say you have a switch over here and you have another switch, and you connect them, but the port over here is fast Ethernet 0/1 and this is gigabit 0/1. Now due to a feature called auto negotiation, okay, this auto negotiation basically checks that which is the average speed that is like feasible for both of them to transfer the data. So the auto negotiation kind of helps you to determine, and you do not need to like be able to figure out that what should be the cable that you need to use. Should it be crossover, or should it be straight through, or so. So there are multiple features that are configured by default. And you could say the MAC learning process, or the traffic forwarding or the flooding process as well works by default in it. Okay, and the STP, which is span entry protocol for avoiding the loop, as well is on by default. This you could say that. So as you know, that switch kind of works pretty well, and we'll just go ahead and we'll try to connect different devices with this particular switch, and we will see how the process works actually. So I'll just grab a switch over here that can work, and I'll take 2960 and I'll drag it across over here. Okay, and I'll connect 4 PCs. So I'll need to go to this is network devices, that's our end device. I'll click on the end devices, and from home end devices I'll just take a couple of PCs. So I can just click on control and I can drag multiple devices like this. Okay, then I can press the escape button. And then I can just Alright, so as we have a switch over here, and I'll just connect these cables with the switches. So then with the PC3, and then we'll connect PC4 by selecting the cable. So I'm just using a normal automatically choose the connection type cable, which is the first one. Okay, and you see you do not actually see the port numbers associated with the cables. So you just need to go into the preferences. You can just go into the preferences of packet tracer, and then over here you can select an option that always show port labels in logical workspace, and then you can close this window and you will be able to see this, that this port is using, or the PC is using FA0/1, the second one is using FA0/2, the third one is using FA0/3, and the fourth one is using FA0/4. If the interface would have been down or turned off, then you could have seen a red mark over here, but you see this, it's all green, which means the devices by default are turned on and they are ready to communicate with each other, okay, as we configure IP addresses on them. And let's go ahead and take the CLI. However, I'll just drag this topology over here so that you would be able to see what the changes are over here. So I'll just go to the thing and then I'll get the CLI accept, and that's basically our CLI for the switch. We also have three modes over here. Enable, we directly are into user mode, and then we go to enable mode, and from here we can go to configure terminal, and then we can change the name of the switch by using commands like host name, and we'll name it as SW1, and there you go, the changes strictly appears over there, and that's all. Then after that, if you want, so to see switches MAC address table, you can use a command called show command, and that basically all the show command works into user mode, so sorry, enable mode, and then I can use a command called show MAC address table. Okay, you can take help of tab button to auto complete the command over here. So as I hit enter, you see there are no MAC addresses that are learned as of now, and with no like additional parameters, the command lists all the known MAC addresses in the MAC table, including like some overheads like static MAC addresses that you can ignore as well. But to see all the dynamically learned MAC address only, you could use this particular command. But if you want to just see the dynamically learned ones, then you can use a command show MAC address table, and then you can use these options as well. Okay, you can use dynamic, you can use interfaces, and you can use static as well. So we, however, are not going to see any MAC addresses because there is nothing as of now. And as we start sending the message, now I'll just have to configure IP address. So I'll go on to these PCs, and then I'll go to desktop section of this, and then IP config section. And over here we will just configure an IP address, say 192.168.1.1, and the subnet mask. What the issue is 192.168.1. Yeah, the IP address automatically came up of /24. We don't need to configure any default gateway as we are not routing between the networks. So that's the IP address for first PC. We'll go to second PC and configure an IP address of 192.168.1.2, and as I hit tab, the subnet mask automatically gets configured again. For PC3 we will do the same thing, 192.168.1.3, tab and close, and then we go to PC4 for desktop and IP configuration, and then you see 192.168.1.4 being configured on the fourth PC along with the subnet mask. Alright, so all the IP addresses have been configured, and you can go to the switch and then again check the MAC address, and you see as soon as we configured the IP addresses, switches automatically stored the MAC address because there were communications that was done. Cool. So you see the FA0/1 has an entry of MAC address having this, and then there's 4 entries that have been done. Makes sense? Now you can also check that now if you focus on the first 2 columns then of the table, then the MAC address and the ports column, okay, of the table, then you could say that this is the MAC address and that's what with the port number the port is connected to. Okay, so our PC1 is connected with this MAC address, PC2 is connected with this, PC3 is connected with 0/3, and PC4 is connected with 0/4. That's exactly how it works. And if I try to forward packet, then I can just select a packet from here. This is basically to add a simple PDU. So I can select a message, I can click on the source, and then I can click on the destination. And as I hit enter, you see the message was successfully delivered. But if I, let's say, go to the CLI and then I say something like show MAC erase startup config and erase running config, or we can just do erase startup config and then I will reload. Oops. Then I will reload it and say switch system configuration has been modified. If you want to save it, no, and then confirm with the reload. And you see all the PC ports went down. And then as soon as the switch will boot up, all the ports will come up again. Now you see, the color that you see over here is not directly green. From red it turned out to be amber, and then from amber color it will turn out to be green. So the time that is taken for it to become green from red, it's called as convergence time. You'll learn more about these details while we will talk about the STP convergence status in the spanning tree protocol section. So as it has been turned green, we can again go to the enable and say show MAC address table, and it's again empty. If we try to refresh it, you see there is nothing that is coming over here yet. And I will just try to forward the packet again because the IP addresses are already configured on the devices, you see. So if I again see that there is no details as such, so I'll try to forward the data from PC1 to PC2 again, and it again became successful. Now in a short period of time, the switch kind of executed everything that it needs to execute. And you can again check the MAC address table. There are just 2 entries, you see, for PC1 and PC2. Okay, there is no entry for PC3 and PC4 as of now because there hasn't been any communication initiated between these two. The IP addresses already are configured. Okay, so that's why when we initiate message from PC2 to PC4, then we will be able to see the entry becoming there. You see, that's exactly how it works. Now a MAC address basically stays into the MAC address table for 300 seconds, that is 5 minutes, and upon each 5 minutes the MAC address is removed, and then again some internal communication happens, and then again the MAC address is learned. Okay, so you can say, and you can also change the time that is taken to in order to remove the MAC address from the data or the MAC address table, but it's often all done internally, so you don't need to worry about it. If we talk about managing the MAC address table, then you could say that you can use a command called show MAC address table, and then you can see some details which are not over here, I would say. So as I told you that MAC addresses stay into the MAC table for 300 seconds, and you can like change the timer as well, but it's not needed so far to us. So you can say that due to internal communications, the MAC address just stays there, and once the timer expires, then there are like internal communications that are done between the devices to check if the device is still present over there, and if the device replies back with an acknowledgement to the query that has been initiated by switch, then the MAC address just stays there, okay, in the table, and the new counter just starts. So that's exactly how the MAC address table works, and how switches do the decisions of forwarding the known unicast and unknown unicast frames as its traffic. So you can practice this by installing the Cisco Packet Tracer again in your local PC, and then just practice about how this MAC address table works. And in the coming section, we'll be discussing about VLANs and all, and their fundamental knowledge about how VLANs actually works. So thank you so much for watching this particular video. I hope you enjoyed the content, and I'll see you guys. So thank you so much for watching this particular video, and I'll see you guys in the next one.